About factoring. Hello everyone, my name is Serdon and we are going to factor out difference of two squares. Is that we are going to simply factor difference of two squares. So when we say difference of two squares, we have here a binomial and then the operation at the middle is subtraction and then the first term is a perfect square and then the last term is also a perfect square. So example problem number 1, we are going to find the complete factor of 4x squared minus 1. Squared minus 1, we're going to factor this out. The first thing that you're going to do is to get the square root of each term. So we have the square root of 4x squared, that is 2x. So as you can see, we have two possible answers for the square root of 4x squared. We have negative 2x as well as positive 2x. But in this case, we are just going to get the principal root. When we say principal root, that is the positive square root. So therefore, the principal root of the square root of 4x squared is positive 2x. Another one, the square root of 1 is 1. Therefore, the factored form of 4x squared minus 1 is simply getting the plus and minus. So we have here 2x minus 1, then 2x plus 1. So this one is the factored form of 4x squared minus 1. So if you're not sure with your answer, you may multiply this 2. If you're going to multiply these 2 and you have obtained this product, therefore your answer is correct. Sample problem number 2. Find the complete factors of 25x squared minus 16y squared. Factored form of 25x squared minus 16y squared. Again, you're going to get the square root of 25x squared. That is the first term. Get the principal root. The principal root of that is 5x. Then the second term is 16y squared. The factored form, I mean the square root of that is 4y, or the principal root is 4y. Therefore, the factored form of this one, which is 25x squared minus 16y squared, is the sum and difference of the roots. We have here 5x minus 4y and 5x plus 4y. Find the complete factors of 19x squared minus 49y raised to 4. So as you can see, we have here a given which is a fraction. So one of the difficulties that our students is facing is actually finding or manipulation on fractions. So we can teach you more about this in this solution. The solution for the factored form of 19x squared minus 49y squared, get the square root of 19x squared. So to get the square root of 19 x squared, we're going to get the square root of 1. The square root of 1 is 1, then the square root of 9 is 3. And the square root of x squared is x. Therefore, the square root of 1 over 9x squared is 1/3 x. Then the square root of 49y raised to 4 is actually 7y raised to 2, or 7y squared. Therefore, the factored form for this 1 over 9x squared minus 49y raised to 4 is actually the sum and difference of the two roots. That is 1/3 x plus 7y squared times 1/3 x minus 7y squared. 0.25x raised to 4y squared minus 0.04. So this involves decimal numbers. So this is another difficulty that the students is facing. That is manipulation in terms of a decimal number. Of 0.25x raised to 4y squared minus 0.04. Again, you're going to get the square root of 0.25x raised to 4y squared, and that is 0.5x squared y. The square root of 0.04 is actually 0.2. Therefore, The factored form of that is the quantity of 0.5x squared y plus 0.2 raised times 0.5x squared y minus 0.2. Find the complete factors of 5x raised to 4 minus 500. So this problem is, at one glance, this is almost similar with the problems that we have encountered from 1 to 3, but there are some manipulations here wherein you can use the greatest common factor. Okay, so as you can see, 5x raised to 4 minus 500, there is no square root for 5x squared wherein the result is a counting number from, 0 to the positive infinity, or the principal root, which is a whole number. Therefore, looking at the terms, you can actually factor out 5 from x raised to 4 then 500. So, using the lesson that we have about the greatest common factor, you can separate 5 as the greatest common factor, then enclose are the two terms x raised to 4 minus 100. So you can simply get the square root of x raised to 4 and 100. And that is x squared, the square root of x raised to 4, then the square root of 100 is 10. Okay, so by getting the factored form of the term inside the parentheses, you have there the complete factored form of 5x raised to 4 minus 500, and that is 5 times x squared plus 10, the sum of the two terms, times the quantity of x squared minus 10, the difference of the two terms. We can actually apply the concept of finding the factored form of the difference of two squares using these non-routine problems. Multiply using the identity a squared minus b squared is equal to a plus b times the quantity of a minus b. Okay, so we're going to use the identity a plus b times a minus b, this identity, to find the product of 99 times 100. So if you're going to use the long method of multiplying these two, that will take a lot of time to solve this problem or to find the product of these two. However, by using this identity, you can get the product of these two by manipulating smaller numbers. Equivalent to 100 minus 1, because 100 minus 1 is 99, and 101 is actually equivalent to 100 plus 1. Therefore, we can say that 99 times 101 is the same as 100 minus 1, which comes from 99, or the equal value for 99. This one comes from here, and 101 can also be written as 100 plus 1. As you can see, this is actually sum and difference of two binomials. So you can say that this pattern, the difference of two squares, so this one is similar to 100 square minus 1 square. And that is 100 squares equivalent to 10,000. 1 square is 1. Therefore, subtracting 10,000 by 1, we have 9,999. So we can say that 99 times 101 is actually 9,999. Factor out completely. So as you can see, you have here two binomials which are both squared, but they are actually perfect square, because finding the square roots of these two terms, you can get a number which is a square root. The quantity of a plus 3 squared minus the quantity of b minus 1 squared. Okay, you don't need to expand these two terms, but you can represent a plus 3 and b minus 1 using different variables. And that is, let a plus 3 that is equivalent to x, and let b minus 1 equivalent to y. So we can rewrite now the given into this given, we can rewrite this one into x squared minus y squared. So x, this replaces a plus b, and y, this replaces b minus 1. So x squared minus y squared is equal to, as you can see, this is difference of two squares. So the factored form of this is actually x plus y times x minus y. Okay, so we said that x is equivalent to a plus 3. X is equivalent to a plus 3 and y is equivalent to b minus 1. By that, we can replace here all x's with a plus 3 and all y's with b minus 1. And that is x is being replaced by a plus 3 plus y is being replaced by b minus 1. Then we have here x is being replaced by a plus 3 and we have here y which is being replaced by b minus 1. Then simplify or simply add or subtract terms or combine terms that are common. Okay, so we have here by removing the parentheses, we have here one group and this one is the other group. Okay, therefore, by combining terms here that are common, that is 3 minus 1 that is equivalent to 2, then we have here 3 minus minus or 3 plus 1 that is equivalent to 4. So therefore, the factored form for a plus b, a plus 3 square minus the quantity of b minus 1 square is equivalent to a plus 2. 2 comes from 3 minus 1 plus b, close parenthesis, and we have here a plus 4. 4 comes from 3 plus 1, then minus b, close parenthesis. The factored form of difference of two squares. So always put in your mind this pattern that a square minus b square is the same as a plus b, a minus b. So this one are the factored form. This one is the given polynomial. So that's it. Thank you very much and thank you for listening.